Alright, what's up guys? In a video I uploaded in my YouTube channel, I proved something called the Pythagorean Theorem. So if you want to know the proof of it, you can go check that out. But this time we're going to use it to solve for the missing length for these following triangles. So the Pythagorean Theorem states that if you know the legs of a right triangle, A and B, right? Then the sum of the squares of A and B is going to equal the third side squared. However, C squared in this case, the sum has to be added to this third side called the hypotenuse right here. So this is this side right here that I'm highlighting. It has a special name. It's called the hypotenuse. All right? Hypotenuse. 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 And you can find the hypotenuse by locating where the right angle is and going across it. That's always going to be the hypotenuse. Okay? So just keep that in mind, because if you say the following, it has to be the specific combination, because you cannot say a squared plus c squared equals b squared. This does not work. Okay? If you're going to square the legs and add them, they have to equal, the sum has to be equal to the hypotenuse. You cannot mix and match the numbers any way you want. C always has to be the hypotenuse. Always. So just keep that in mind. So what I like to do to solve these is first find the hypotenuses. So here I see the right angle. So if I go across it, that means this side right here is C. And I'm going to do that for all of them. So right angle. So this is C right there. Okay, so we're going to find the right angle and then label it. Right angle, C is right there. Right angle, go across, C is right there. And then C is right here, and C is right here. So in this case, we're solving for the missing hypotenuse value for each of these triangles. So let's start with number 7. In this example, we have side lengths 4 and 8, which means that 4 to the power of 2 plus 8 to the power of 2 has to equal c to the power of 2. So c to the power of 2. So let's find out what c to the power of 2 is. Well, first we have to know what 4 squared is. Well, 4 squared is 4 times 4, which is equal to 16. Plus 8 squared, which is 64. And that equals c squared. C squared. Right there. Perfect. So now we have to add 16 plus 64. And we get 80. So 80 is equal to c squared. Just like that. Now we have to do something called the square root to find the value of c. And that looks like this. It's an operator. So what you do is you take the square root of both sides. And what the square root does is that it gets rid of the exponent right here too. It's like the inverse of it. Think of it like the opposite, but in math we call it the inverse. So if you think of the inverse such as addition, it's going to be subtraction. The inverse of multiplication is going to be division. The inverse of square is the square root. So now basically this symbol and that symbol go away, and we're left with only c. And c is equal to whatever this number is. It's going to be a number that when you multiply it by itself is equal to 80. And in this case, we're going to use a little calculator that I have right here. So we're gonna enter right here. You can see the square root. Square root. We enter 80, and we get 8.94. So the square root of 80 is about 8.94. Not exactly, because if you look at the number, it repeats. So we're just gonna go with 8.94, which means that this side is equal to 8.94. But the instructions say nearest tenth. So it's actually just 8.9. So in this case, C is equal to 8.9. And if you enter 8.9 in the calculator and multiply it by itself, we should get somewhere near 80. Let's check it out. So 8.9 times 8.9. And look at that, 79.21. Pretty close to 80. It's not exact because from the calculator, we can tell that it repeats forever. So if you copy more decimals and then multiply by itself, you'll see that the number gets very close to 80. So here, let's just try 3 decimals. 8.944 times 8.944. Look at that. 79.995,136. It gets closer and closer to 80 the more decimals you have written down. Okay, so in this case, the length of this side is 8.9. Let's try another one. Let's do number 8. So now we have the sides 6 and 3. So we're going to write 6 plus 3 is equal to C. But this is not true because we have to put the squares right here. All right, there we go. Cool. So now we do 6 times 6, which is equal to 36, plus 3 squared, which is 3 times 3, which is equal to 9, and that's equal to C squared right there. So 36 plus 9 is 45, is equal to C squared. So now we're going to take the square root of both sides to get 1C only, because right now we have C times C, but taking the square root only gives us 1. That gives us C. So it's going to be some number multiplied by itself gives you 45. So let's go to our calculator. I accidentally closed it. Here, let's go to our calculator. So square root of 45, and we get 6.708, but it says nearest tenth, so it's only going to be 6.7. So C is going to be equal to 6.7. Cool. 6.7. Now, is 6.7 the exact value? No, but they're asking us to round. The exact value is, it keeps repeating. So if you want the exact value, we're just going to say square root of 45. There's a way to change the form of it, but that's for another exercise. Let's do another one. Let's do number 12. We're going to skip these. Let's do number 12. So our legs are 2 and 6. So 2 squared plus 6 squared is equal to C squared. Cool. 2 squared is 4 plus 6 squared, which is 36, is equal to C squared. 4 plus 36 is equal to 40. That's equal to C squared. So now we take the square root of both sides to get C by itself. So that goes away, that goes away. We're left with only C down. So C is equal to the square root of 40. What is that number? Let's find out. The square root of 40. The square root of 40 is 6.324555532, but nearest tenth is 6.3. So our value for this one is equal to 6.3. So right here is equal to 6.3. Cool, cool, cool. Now let's do an exercise in which we are given the hypotenuse, but we don't know one of the legs. And we'll only do one exercise and we'll call it a day. So here I have a right triangle. And it has side 3 and hypotenuse length 5. And I'm going to label this missing side, I'm going to call it y. There we go. So let's use the Pythagorean theorem to find this missing y value. So we have one leg, which is 3 to the power of 2, plus, let me put it over here. So we have 3 to the power of 2, plus, well, we don't know what y is. So we're going to just leave it as y, but we need to square it in order to use the Pythagorean theorem. And that's going to equal the hypotenuse, which is across the right angle. So our hypotenuse is 5, which is equal to 5 squared. Cool. Now let's solve these squares. 3 squared is equal to 9 because 3 times 3 is 9. Y squared is just, well, y squared. So we're going to have y squared. And that's equal to 5 squared, which is 25 because 5 times 5 is 25. Cool. Now we need to get y by itself, or the y squared term. We need to get this term by itself. We're adding a 9, so I'm going to subtract the 9 from both sides. So subtract the 9 and subtract the 9. So that goes away. So our next equation now is going to be y squared is equal to 25 minus 9. 25 minus 9 is equal to 16. What number times itself equals 16? Well, if you have 1 and square it, you get 1. If you have 2 and square it, you get 4. If you get 3 and square it, you get 9. And if you get 4 and square it, you get 16. That means that when you take the square root of both sides, you get y is equal to 4. And that's our value, which means y is 4. Pretty cool. If you look at this triangle, it has sides 3, 4, and hypotenuse 5. Pretty awesome. That's known as a Pythagorean triple. And there's a lot more Pythagorean triples, an infinite amount actually, but this is a very popular Pythagorean triple because the numbers are 3, 4, 5. And that's how we use the Pythagorean theorem. Let me know what you guys think, and I'll catch you later.